When you're learning the Canadian Electrical Code, Section 8, Rule 8200 is a very important one. It's called Calculated Load for Services and Feeders. And this is where you're going to calculate the load in watts that is required for a dwelling. So I'm going to make you a spreadsheet that goes through all of the questions that you have to answer to calculate what the appropriate load is for a dwelling. Let's do this flow chart for a single dwelling, and then we can do more flow charts for other dwellings. The single dwelling in the code is Section 8, Rule 200, 1A is for single dwellings. So it's called 820 calculated load, and we're going to calculate that in watts. And really what this section is saying is that you are going to add up all of the important parts that contribute to the amount of power in watts that's being used in this household. But it really only looks at big loads, and it takes a few little assumptions, and it looks at 6 areas. So if you look at this section of code and you really work with it for a while, you realize that you're adding up 6 things. You're adding up 6 critical elements that could contribute to the load. And I will show you how to make the decisions for all 6 of those in this flow chart. And then at the end, we just add together all of these 6 elements. The first one is the floor space. A larger home is assumed to use more power. The next one is your comfort your comfort conditioning. And by comfort conditioning, I mean it's cooling loads and it's heating loads, but you're never cooling and heating at the same time. So it is just the largest of cooling or heating loads. It is an electric range because that's a pretty big element to consider. And it is water heating. That's a big element to consider as well. Electric vehicles, of course. And then there are other big loads. It's not other small loads, it's other big loads. So it's other loads in excess of 1,500 watts. All right, so let's look at each of these. The floor space one is, sorry, I shouldn't have an A here. Single dwelling is Section 8, Rule 100, or sorry, Rule 200. 1 is for single dwellings, and 1A, this is 8,200, 1A is for floor space. So here's what you have to do for floor space. You have to look at the 3 stories. You have to look at the living area and not basement. And then something interesting to note about floor space, I'll just put a note here, that note 8,100 is living space calculation. And it tells you that it tells you how to calculate the ground floor and above ground floor by subtracting the width of the walls, but also to add 75% of basement. But Rule 8,201A here, don't, like in 8,200, don't use basement. All right, so don't confuse 8,100 with 8,200. So don't use the basement in this floor space calculation, not basement. This is not the place where you use 75% of the load of the size of the basement. So you're going to do the ground floor and the upper floor. So here we go. We're going to now, you have to calculate ground floor. Size in meters squared. And then you have to calculate upper floor in meters squared, not the basement, okay? And the way you do that is you look at outer dimensions. This is length times width of the outer dimensions of this floor. And then you have to look at the thickness of the walls. So you actually have a wall here, right? And so, of course, the dimensions are going to be minus the thickness of the wall. So the dimensions for each one would be like area equals, it would be length minus 2 walls of thickness, length times width, right? Width minus 2 walls of thickness would give you your dimensions in meters for each of those rooms. And then you are going to add those two together. So you're gonna add those, add ground floor plus upper, and you'll get the total size in meters. Now, if it's really small, then you do one thing. And if this is a large dwelling, you are going to use the a different thing. Small, and this is in 1A1, and this is in 1A2. And what 1A1 and 1A2 says is you are going to use, if it is a small dwelling, it is for it, like how small, it means up to 90 meters squared. So it's less than 90 meters squared. And large is greater than 90 meters squared. So less than 90 meters squared, then use, this is really important, use 5,000 watts for this small house. If it is greater than 90 meters squared, then use 5,000 watts from the first 90 meters squared, plus n times 1,000 meters, watts, for each n meters squared. All right. So here, the first thing that we do, we're going to add together 6 different things. 1, 2, 3, 4, 5, 6 different things. First of them is the amount of power based on the floor space. And you add your ground floor to your upper floor. And then if it ends up being really small, less than 90 meters squared, you say, okay, 5,000 watts we need just because of the floor space. If it's larger than 90 meters squared, we say 5,000 watts for the first 90 meters squared, plus 1,000 watts for each amount of meters squared beyond that. All right, so it's 5,000 watts for each for the first 90 meters squared, and then 1,000 watts for each 90 meters squared more is the right way to say that. Okay, let's look at the second thing that we're going to add. The second thing that we're going to add here, I'll do in a different color, And it is, it's going to be your comfort conditioning. By comfort conditioning, I mean heating and cooling. So you're going to do some heating and you're going to do some cooling. Probably in different seasons, not at the same time. Now, going down the heating section, we have to ask what type of heating is it? Is it electric thermal? Is it duct heaters or is it electric furnaces? If so, now you have to go out of section 8 of the electrical code and you have to go to the specialty section 62. That's not one of the general sections. 62118 for this calculation. And then the heating load then is calculated using 62118 and multiplied by 100% demand factor. So you have to go and calculate the heating load per 62118 and then use a 100% demand factor. That just means take the loads in watts that you calculate from 62118 and multiply it by 100%. Use 100% of it. All right, but for any other factors, what you're going to do is calculate the heating load in watts, and you are going to use 100% for first 10 kilowatts and plus only 75% for additional 10 kilowatt for each additional 10 kilowatts. Okay, or I could have said it like over here for n times 75% for each n of more 10 kilowatt sections, but no need to complicate things. So let me repeat that again. If we are heating, we say what type of heating. There are some specialty types of heating that we should use 100% of it. Those are specified and the calculations are in 62118. All other heating, we are still in 8200. 1A3 says that you should calculate the loads in kilowatts and use 100% of the first 10 kilowatts, only 75% for the additional 10 kilowatts. And why is this? This is because you're not always going to be using heating, or you're not always going to be using the maximum amount of heating, we hope. And for the cooling load, all we do is, we calculate that AC load, right? The air conditioning cooling load. In watts, and we use 100% of it. So that one's pretty straightforward. And now what we do is we ask, well, what is higher? This is our heating load. And this is our cooling load. And we ask which one is higher. And whichever one is higher, use this load. Not both. Don't use both of the loads because we're not heating and cooling at the same time. If we are, we have a problem in a single dwelling unit. This isn't a large commercial building or anything. It doesn't have that many multiple zones, although there could be some multiple zones, but you are heating or cooling. You're going to design this for heating or cooling. So you'll use that loads in watts. So now we have two things to add. We are adding our load due to the floor space, and we're adding our load due to our comfort conditioning, which is cooling or heating. Let's see what we have to do next. Next, we have to do an electric range. Oh, and let me just show you what this rule was that says you use the higher of the two. That's in Rule 8-106, I believe. Yeah, that's 8-200. 1A3, 1A3, and 8-106, 3 is what you would refer to for this. Now, let's look at an electric range. Do we have an electric range? Yes or no? Because you don't necessarily have an electric range. Let's get fresh new colors for an electric range. And we can have no, I have no electric range. That means 0 watts for your stove. It's probably a gas range at that point. If yes, then you're going to look at 8-200, 1A4 will tell you to add 6,000 watts for up to 'I'm going to do this in another little bit of a spreadsheet. No, and then we have yes. And this is a small electric range, and this is a large electric range. Small, large. This is less than 12 kilowatt range. And if it is greater than 12 kilowatt range, then you are going to, smaller than 12 kilowatts, you are going to use 6,000 watts for that electric range. And if it's a large electric range, you're going to use 6,000 watts plus 40% of above 12 kilowatts. Why is that? It's because they assume that you're not cranking this electric range all the time. If it's really large, larger than 12 kilowatts, you're probably not using the amount that's larger than 12 kilowatts all the time. You're probably not utilizing all of that. So that's what you do for the electric heating. And then we're going to ask ourselves, are we heating any water? Are we heating any water? And let's do that down here. Do we heat water? Lots of people heat water in a fancy way. And we could be a yes on that. And we could be a no on that. If you're not heating any water in a fancy way, you are going to give 0 watts. And if we are yes heating it, then what are we heating? If we are heating electric tankless water heater, that's a continuous run water heater that's mounted to your wall. Steamers, pools, spas, hot tubs. Then you are addressing 8-200, 1A5, and going to have to do something about it. You are going to have to use 100% of their load. It's a 1-to-1 demand factor. You don't use anything less than that. All right. What's the last thing? Oh, we have EVs. We should also see if we're using EVs. If we are using an EV, then there are a few options here. We, yes, have an EV. We no, don't have an EV, or we yes, have an EV with a EVSE, energy management. It's energy managed. If yes, we just have an EV, we're going to use 100% demand factor. If we just yes have an EV, we have to provide that much power constantly. If we don't have one, of course, it's no watts have to be added for your EV. If you have one, if you have an energy management system, then you're going to look at Rule 8.106.11. All right, for that factor, which will be in watts. And this one, of course, is in watts. Okay, now, are there any other big loads? And do I have room for them on this paper? Any other big loads? Let's go down here. Do I have any other large loads? Other loads greater than 1,500? So I ask myself that in 8,200, 1A, 6. I ask myself large loads. Greater than 1,500 watts. And if that is a yes, and there was an electric range above, so I'm gonna put a no in here, and that's 0 watts additional. But if I put a yes here, then I have to ask myself, well, was there an electric range? Did you also have an electric range and more loads? Electric range above? Did you have one? Or no electric range? Because it's different if you have an electric range in this house already and no electric range. If there was an electric range, then you're going to have only a demand factor of 25% for more loads above 1,500 watts. Then we'll have a 25% demand factor. If there was no electric range, then I have to add 100% for first 6,000 watts above 1,500 watts and 25% for the rest. Oops. Now we're running out of space here, but we're at the end. 25% for the rest. 25% for the rest. All right. Because it's a non-continuous load per 8, 104, 5, and 6. So I'm just going to put non-continuous. That's why. And if you want to learn more about that, it's in Section 8, Rule 104, that describes that non-continuous load. note 5 and 6. Okay, so beautiful flowchart we have here. And in order to calculate the load, in order to come up with the calculated load in watts per section 8, rule 200, calculated load for a single dwelling, we are now going to add. So we need a really great marker here to say we are going to add. We're going to add this one or this one for the floor plan. We're going to add the heating or cooling load, whichever one was higher. We are going to add either the small or large electric range. We are going to add the heating of water. We are going to add the electric vehicle. We are going to add any other big loads. That's 1, 2, 3, 4, 5, 6 things we are going to add together. And once we add those things together, in watts, we figure out the amount of load that we have to provide to this single dwelling in order to meet its needs. So there you have it, a beautiful one-page view of what it means in Section 8, Rule 200, calculated load for service and feeders. Hope you love this. Hopefully it's helpful to you. If it is, please press like below. Do you need to know more about it? Do you need to see example problems? Let me know in the chat below. And thank you so much for watching.